Hello and welcome to Communicating Science with the Beneski Museum of Natural History. I'm Annika Baldwin, an intern at the Beneski this summer. Today, I'm talking to Tekla Harms, a professor of geology here at Amherst College. Her research focuses on the formation of mountain belts, and she teaches intro geology as well as a variety of intermediate and upper level courses that have a focus on geodynamics. I was excited to learn more about Tekla's research and approach to science communication because I took Geology of the American West with her over January term. The class is all virtual, but her warmth and passion for geology made her one of my favorite professors I've ever taken a class with. I'm thrilled to have had the opportunity to talk more with her. Hello, Tekla. Thank you so much for talking to me today. I just want to start by asking, how did you get interested in science?
Wow. So this is a story without a beginning. As long as I can remember, I've been interested in science. I don't, there are a couple of key points, but I don't know that it really tells the story. When I was 11, my family did what the old Chevy ads used to say. We saw the USA in our Chevrolet. That is to say, we left Rochester, New York in a Chevy Impala and drove out as far as the Rockies and around the Rockies to see the national parks in the Rockies, from the north, from Glacier in the north to the Grand Canyon in the south. And I remember distinctly when we got to the Tetons that I just thought that was heaven on earth. And it had to do both with the mountain, mostly with the mountainous landscape, but also with that dry, clear, high mountain air. Where I grew up in Rochester, New York, summers are sticky and humid and hot, kind of like today here in Amherst. And that's just not my favorite atmosphere. But I didn't know that until I went to the Rockies. And then the other touch point, so I knew then that I really liked being in the mountains. The other touch point that I look back on is when I was growing up in New York State at that time, in the previous millennium, 7th grade earth science was your first high school science. We didn't have middle school. We just went from 7th through 12. And in 7th grade, you took earth science and then biology and then chemistry and the hard stuff, but earth science was first. And somehow I understood going into that class that I really wanted to do well in that class, which I have to contextualize when I say it. I did well. I was an egghead. I did well in all my courses. So singling that one out as one that I really want to do well in, I don't know where that feeling arose, but it was clearly something that was more important to me than chemistry or biology. I really liked it at that point. So then fast forward to end of high school looking for colleges, and I wanted to go to a small liberal arts college, which I did do. Many were not available to me because they were not co-ed yet. And I whittled down the list to only those schools that had good geology departments and good art history departments. Those were the two things I thought I might want to major in. So even then I was kind of laying the groundwork to do this. So where did it start? I have no idea. Neither of my parents are geologists. We didn't camp when I was growing up. None of that sort of typical stuff that people always ask me, oh, was your father a geologist? None of that stuff. It just was in me.
Wow, it's been a long time then. I'm amazed that you're still passionate about it. That's so cool.
Oh no, that's not hard to imagine. But it does actually handicap me as a teacher at Amherst College because I have just always known this about myself. Mm-hmm. And I think for most students, college is a time of self-discovery, and you might go through 3 or 4 majors. A colleague of mine, Peter Crowley, who's on phased retirement now, but he went through all the science majors. He was at one time a chemistry major and then a physics major before he settled on geology, and that never happened to me. So when it comes time for a student to pick a major or to kind of think about what science they like, I'm of absolutely no help because I didn't go through that process myself. It was just always there.
Wow. So how did you decide that was like what you wanted to do for a career?
In the early years of my career, when I was going to graduate school, first of all, that was pretty unusual for women. So just the fact that I was going, nobody pushed me to think about what happens next. It was, oh, look, you got a master's degree. So first of all, what are you going to do with this degree was not a question because I don't know that anybody presumed that anything would happen with that degree. This is really a generation ago. So the second thing is that we were on the cusp of, but not yet into a really widespread use of our knowledge about how the environment works. So there wasn't really an environmental industry per se, either in terms of the public domain and government agencies or consulting firms or remediation firms. So there's a whole realm of employment for geologists, for earth scientists, that wasn't really very robust in my day. So if you were going to be a geologist, it was really going to be about rocks or fossils or mountains. And I'm good with all of those things. So the kind of career path was really about putting one foot in front of the other. You know, you graduate, what do I do next? Well, I actually worked for several years until I made up my mind to go to graduate school. And then you put one foot in front of the next and you do graduate school. And then lo and behold, you do that some more and you've got a PhD. So wow. it was less by design and more by what's the next thing to do, more studying. Well, I love studying. I love traveling around and understanding new areas. So, okay, let's do more of that. That's fine.
What did you do for work in the interim between college and grad school?
I had 2 different jobs. The first was what at Amherst would be called a green dean. I worked in the admissions office in my alma mater. Then I left there and moved out to California with no job prospects and got a job as a geologic assistant in a mining engineering company. It's a company that designed big open pit mines globally. And I didn't do any of that. I did all the grunt work that supported doing that. And after I did about 2 years of grunt work, I said to myself, it is time to go to graduate school.
I see. So studying just appealed to you more than
grunt work?
Grunt work,
yeah. So you can edit out this story if you want to. One of the things that I did, so this company was on the cutting edge of taking assay data from numerous drill cores, putting that into a computer and doing spatial geostatistics to try and figure out where the highest ore body was, where the best ore was, and then mine in that area specifically. But what it means is they had long lists from long cores where they assayed the value of the ore in each meter or whatever. And that in those days was all done by hand. So we had these handwritten logs of the drill core. But that had to be put into the computer by something called key punching, which is essentially typing. But professional typists did the typing. But what grunt people like me did was double check the typing. So my job for days on end, whole days, was to sit in a small room with another person of my caliber, one of us reading off the original copy, while the other one looked at the typed copy to make sure that the numbers had been put in correctly. So it would be a whole day of one person saying 4.315, 7.298, 8.0, 12.735, all day long. So,
oh my gosh.
So yes, while I was working as a geologist and making pretty good money, there was a point when I said, there's got to be something better than this. And graduate school was the way to get there.
Yeah, that's pretty understandable, I think. What did you do in grad school?
Oh, whatever I wanted to. Grad school is wonderful. I recommend grad school to all budding scientists. You get put in charge of thinking through a research project that's yours. It's all thinking what you think ought to be thought. You're kind of the boss of the ship. It's fabulous. So I did a master's degree in which I was researching continental extension in Idaho and Washington State, northernmost Washington State, an extension that seemed to follow quickly on the heels after a mountain building period to try and see how the two were linked. And then for my PhD, I went north to northernmost British Columbia to look at a piece of oceanic crust that appeared to have been thrust up on top of a continent, and to figure out how that happened as part of this mountain building, long period of mountain building in the West. And it was fabulous.
Wow. So what do you do like in a day-to-day while you're trying to figure all that stuff out? Because it's such a large scale over so many millions of years. How do you?
Yeah, well,
start studying that kind of thing?
First of all, you're not solving the whole story, right?
Mhm.
You're telling little stories that build together to that big story. I always call it another brick in the wall. You're just putting another brick in the wall, hopefully building a good wall. So what particularly interests me is how you can make close and careful observations of relatively small scale features on a local basis, and do that in a number of locations and put that together into a bigger story. So part of my work is what's called field work, in which case I'm out in the mountains, walking around, at the first cut, observing just what rocks are where.
Mhm.
So limestone over there, metamorphic rocks over there, what's the contact between them? How did they get to be together? What history did they tell? But I'm also gathering samples that then at the end of the summer I can take home and do even more detailed observations for. Some of those observations are chemical. What's the chemical makeup of this igneous rock? Because as you'll recall, one chemistry means one thing and a different chemistry means another thing. My specialty is actually to look at the fabric attributes of the rock that were developed during the kind of deformation that built the mountains in the first place. I mean, in a grand sense, you can say mountains get high because the land gets shorter and gets squished. But I try and look in detail at that shortening and squishing. I want to see how it evolved through time. I want to see how high the stresses had to be to pile up the pile. And that you can actually do from making a lot of small scale observations over a broad enough region. So that's what I
Really?
like to do.
That's so cool. So did you do most of your work in the field or in the lab, do you think, when you're working on your field?
They're the two are married together.
Yeah.
The field season, of course, is short because relatively short because it's limited by the academic year. I think the longest field season I've ever done is 4 months in northern British Columbia, which was a spectacular time of life to be able to do that. There aren't that many times in life when you can walk away from your home and your family for 4 consecutive months and just be out in the field. So now I do 4 weeks at a time. But so there's a certain amount of field work, and then when you're a graduate student, after the field work during the academic year, your pretty much sole responsibility is to look at those samples that you gathered and figure them out. So if I did 4 months out in the field, then I did 8 months back looking at the rocks and analyzing the rocks and thinking about what it meant and reading background papers and maybe doing some numeric analyses. These days, because I'm teaching during those 8 months, there's the ratio is, well, the ratio is about the same, but it's 4 weeks instead of 4 months and weeks during the school year instead of months during the school year.
Do you like being a professor? Do you like teaching, or does your research, do you think, come first for you?
That's been an evolving answer.
Yeah.
When I left graduate school, I wasn't particularly attracted to teaching, but I understood that if I wanted to be a research scientist and didn't work for the US government, I would be working in a teaching setting. But over the years, I have come to find that I enjoy teaching immensely. So my career worked out for the best because the amount of time I spend teaching is incredibly rewarding, and the amount of time I spend doing research is incredibly rewarding. So I'm right in the right spot where I needed to be.
What do you like about teaching?
Oh, I love sharing these ideas that are so invigorating to me with other people. And teaching is your excuse to do that. You have license to gab. And what you talk about is things that are really exciting to you. I like to watch light bulbs go on for students when they connect ideas and say, so that's why this looks like that. And you say, yep. And I like giving. It's been very rewarding for me in my lifetime to feel intellectually connected to the earth, to be able to look at the earth and understand why it is the way it is. It's not, for me, a kind of a dispassionate, cold, hard analysis. It's a passionate interaction with this planet, which is amazing. And I like that I can play a role in opening those opportunities for other people. It doesn't have to be as sustained and passionate and deep as it is for an actual research scientist. But the idea that there are people out there driving down the road, looking at the earth and looking at it passively and not wondering why it is the way that it is, and not being able to find out why it is the way it is, that drives me crazy. That shouldn't be.
Mm-hmm.
So I like teaching the intro course as much as teaching seniors geology majors because of that, because I know I'm helping to create a citizenry that's more connected to this planet.
Is it hard to switch between those two, the intro and the upper level courses, where like the language you have to use to communicate with them?
You do have to be mindful about it. You do have to be thoughtful about it. But I've been doing it for a long time. So I'd like to think I've gotten better at it. I do try to keep terminology to a minimum in the intro course,
Mm-hmm.
not to get rid of it altogether. I think Amherst students are fully capable of coming to grips with a new language, with a new set of terms. And as everything with language, it creates the scope in which you're able to communicate. So there are some things that you want to communicate so clearly that you need to adopt some of the technical language.
Mm-hmm.
But I try to keep it to a minimum in the intro course, and with upper level courses, it's part of the fun, I think, for students as well, to know that they're working in the language that allows them to be very precise about what they're thinking about.
What do you think you struggle most with communicating?
So that was the question when you showed me what kind of questions you were going to be asking me. That was the question that I thought about the most, and especially in this moment in time. But when I go out in the field, presently I work in Southwest Montana, and
Mm-hmm.
I'm often working in the national forests, but I'm also often working on rangeland or ranch land. And I have to gain permission of the landowners to work on their land. And people out there are incredibly generous about keeping the land open. They want to do it for themselves. They want to be able to go out and hunt on land as long as they have a hunting license, or skidoo across land. And they, part and parcel, they are often very generous about letting me on their land. I have found it very challenging to communicate with them why I need and want to do that.
Mm-hmm.
Partly because I'm actually kind of shy with strangers, and partially because I often don't know where they're coming from. And that, as we just talked about in terms of what are you going to say to students at the intro level, what are you going to say to students at the senior level, what are you going to say to your colleagues at a conference, knowing where people are coming from is where you start. It's where you start knowing what to say. And often out there, I don't know if I'm talking to someone who believes very strongly in minimal government and personal freedom.
Mm-hmm.
So someone who thinks that Eastern colleges are for an elite few that are, on a different end of the political spectrum. I don't know if I'm talking to someone who is a fundamental Christian and doesn't believe in evolution or deep time. And so I don't really know how to start the conversation. And I think for that reason, I feel sad that at this point in my career, I haven't been bold enough to offer to share my knowledge to my best ability, what I'm figuring out about this land, with the people who live there.
Mm-hmm.
If I were doing my career over again, I would try to be bolder about that, or at least ask, do you want me to have an evening down at the Elks Lodge and tell you what I'm doing? Do you want me just to sit down and have a cup of coffee with you and tell me what I'm doing? The depth of conversation is usually, I work at Amherst College, I'm doing research on this land. Do you mind if I go up and walk around on this side hill that you have?
Mm-hmm.
It's another part of the conversation that often happens is they'll ask me what I'm looking for. Well, what are you looking for up there? And the best I can do is say, I'm not looking for anything. I'm just looking at. I'm looking at what's there, just try and figure out why it's there. And that question, what are you looking for, comes from a long-standing history of ranch owners and property owners losing the rights, not owning the rights to minerals on their property, only owning the surface rights to their property. And then some geologist comes along and says, there's gold in them there hills. And all of a sudden their property they no longer have control over their property, even though they own it. It's a part of American land ownership that I really don't understand. I own a piece of property out here in Pelham, and I have no idea if I own the mineral rights to this property or not. You just don't think about it.
Yeah.
And so many ranchers have learned that having a geologist on their property can come around and bite them. And so it always starts with this question, what are you looking for? And the most conversation I have usually is around this thing that I'm not actually looking for. It's a purely academic study that I'm doing. But I can't promise them ever that what I find out, this purely academic history of the area, isn't going to lead some other geologist to say, wow, if that's the history, there could be, and then go looking for it, right? So it's a fairly thin line that I tread to say that I'm not looking for anything, but I can't guarantee that I'm not acting against their better interests in the long run,
Wow, that's interesting. So, there's such a long history of like mistrust of science, especially from people in rural areas. I hadn't really thought about like the practical reasons for that, where really science really could come back to bite them.
Yeah, and I don't think it's that they mistrust science. I think that in those instances, they do trust science. They do think that that you might know enough to find something.
Oh, that's so interesting. Do you tell them that what you're doing could potentially lead another geologist there?
No.
I think, yeah, probably for the best.
No. Yeah, I don't do that other part of the conversation.
Yeah.
Let me just go back and say, happily, it never has.
Perfect.
I've never worked in an area where the geology is actually of some economic benefit.
That's good. I'm sure that's comforting to the people whose land you're
Well,
on.
it's comforting to me
Yeah.
to say I don't feel guilty for not having that second part of the conversation, because I do know enough about what I'm doing to say, wow, it's a really long shot that what I'm about to figure out is going to lead somebody to come and want to mine your property.
That's really good. You were saying earlier that if you could go back, you'd maybe be interested in doing talks with these people, and
I think I still wouldn't be interested because I think I would still be scared of it, but I would try to make the effort. I would try to force myself to make the effort.
Who do you think needs to learn about geology the most?
Anyone who lives on the planet.
Yeah.
Absolutely. Yes.
And why is that?
Because it's about the planet. No, I'm serious. I mean, that is what I think. You ask me what I think, that's what I think. I can't imagine living on this planet, in any part of the planet, and not wanting to know more about why it is the way it is. It could be a thoroughly inactive part of the planet like Kansas, but you might still want to know why there are hills and valleys. When was the soil laid down? Or it might be an incredibly active part of the planet where you're living on the side of a volcano, and you might want to know more about that. Everybody needs to know about geology.
Is there anybody, like a demographic, that you think isn't here learning about geology that really should be? Like, if you could.
You mean for whom is it most pressing?
Yeah, or if you could, stop what you're doing right now and go tell somebody about your work, who would you want to reach out to?
It would be anybody will do. Anyone will do. Any parent about to have a child should know about the future of this planet, should know about how the climate is going to change, how the shorelines are going to change, how the water supply is going to change. Anyone thinking about having a child should know more geology. Anyone thinking about voting should know more about how this planet works, and so that they are not bamboozled by this claim or that claim before they go into the voting booth. I'm terribly hard pressed to think of anybody for whom this is not pressing and immediate need.
Wow,
I'm sorry.
No, that's so interesting. What do you mean about it being pressing for people who are voting? Things
Well, for your generation, there are some very hard decisions to be made about resource allocation, about displaced people being displaced from islands which are going to be submerged, rich people being displaced from fancy coastal communities in the US. It doesn't have to be, it's all ends of the spectrum. So there are difficult decisions to be made about how we're going to manage the changes that we've wrought to the climate, how that's going to affect changes to resource allocation, to where agriculture can be done, to food sources, to clean water. And this is at considerable arm's length from what I do. I'm a really academic geologist about why mountains go up and down. But the Earth is a system and all those things are linked. If mountains go up, they interact with the atmosphere. The fact that there is an Andes mountain range and a Himalayan mountain range gives us the global atmospheric circulation that we have today. And that determines where the monsoons are, and that helps to determine what seawater temperatures will be. And you better know about those things if you're going to start messing with the climate, because those are really big cycle systems in the climate. And if we want to look at the climate record to understand what we could be doing to the climate today, you can't look at that climate record in the deep past without asking, where were the mountains? What was the climate circulation, the atmospheric circulation at the time? What was the distribution of continents? What was the ocean circulation at the time? So all parts of our understanding of the Earth end up being linked, and all parts of them need to be understood to have a better understanding. That better understanding is going to be necessary for wise choices in the very near future. It's urgent.
Wow. Well, I have time for one more question.
Okay.
And that is, what is your advice to future scientists, people who would like to grow up and be like you?
Do it. First of all, do it. Find the thing that you are most interested in yourself and throw yourself at it. I'm a firm believer in the old saying that a rising tide floats all boats. The more knowledge we have, I don't care what the knowledge is, I don't care where it comes from or what it's about, the more knowledge we have, the better off all of us are. So don't worry, don't spend too much time worrying about if you're working on a field in which you're going to save the most lives or give back the most to your community or have the greatest economic impact. All of them do. And you will do your best in the field that you are most passionate about. And that's the rising tide that floats all boats. So find out what you're curious about and then pursue it.
Well, Tekla, thank you so much for talking to me today. I really loved hearing about your journey to geology and why it's so important. Thank you so much.
I enjoyed talking to you. Thank you for your patience and listening to me.
Thank you for listening to Communicating Science. See you next time.